Welcome to this unit. My name is Samantha Caputo and I will guide you through this unit of the course. I am a member of the TICAS staff working in the Bioplastics Europe project. TICAS is a non-profit consortium established in Genoa in 2010. Our mission as a meeting point between research and industry is to stimulate the local system of innovation in the fields of environment, bioeconomy, energy, hydrogen, and materials. The term bioplastic refers to a large family of bio-based polymers with plenty of different facets and corresponding applications. The different combination of polymers affect how the material can be disposed. Even if several bioplastics disposal methods exist, there is a high level of confusion among consumers, leading to improperly disposal of bioplastics which can create problems at both plastics recycling facilities and composting facilities. In this context, the need to improve awareness of consumer is more and more urgent. For this purpose, today we introduce an overall view on biodegradation processes. As previously said, bioplastics and bio-based plastics are not interchangeable terms. Either fossil-based and bio-based plastics can be non-biodegradable, biodegradable, or compostable. Before talking about biodegradation and composting, we need to clarify the term degradation. It means any physical or chemical change in polymers such as color, shape, or else. It can be caused by environmental factors and biological activity. For the latter, we use the term biodegradation. Biodegradation is the decomposition of material by biological action of a living organism into environmentally acceptable products such as water, carbon dioxide, and biomass. It depends on the nature of the material as well as the environmental conditions to which they are exposed to, such as temperature and moisture, that are correlated with application domains of material. The biodegradation of plastics involves three steps. The first step is deterioration, in which polymers undergo chemical, mechanical, and physical change. The second step, called fragmentation, is when the material breaks down into small pieces. Fragmentation can be caused by natural agents such as sun and weathering, and microorganisms which colonize the plastic's surface, converting polymer into its monomers. Last step is mineralization, which involves the ingestion of fragments by microorganisms into carbon dioxide, methane, water, and biomass. Biodegradation processes can be divided into two main classes, aerobic and anaerobic biodegradation. Aerobic biodegradation is the breakdown of organic materials by microorganisms in the presence of oxygen. Aerobic microbes use oxygen to break down organic chemicals into smaller organic compounds. Biomass, carbon dioxide, and water are the main products of this process. On the other hand, anaerobic biodegradation is the breakdown of organic materials by microorganisms when oxygen is not present. Some anaerobic bacteria use other elements to break down organic chemicals into smaller compounds. The process generates biomass, water, and biogas, such as methane, carbon dioxide, ammonia, and hydrogen sulfide. In general, aerobic degradation is faster and brings to non-pungent gas compared to anaerobic degradation. A type of biodegradation process is composting. It is the biodegradation of organic substances under specific conditions to obtain a natural fertilizer, namely compost. The composting process of plastics can be realized at both industrial and domestic scale. Industrial composting takes place under highly controlled conditions where temperature, moisture, and other parameters are maintained at optimal levels for converting organic waste into stable and sanitized products for agriculture. Uncompostable material is referred to substances that are able to biodegrade directly in domestic compost bin, where it will decompose and become organic rich soil. Uncomposting occurs at a much lower temperature and over a longer period of time than industrial composting. Most of uncompostable plastics also biodegrade in industrial composting plants, but not the other way around. To sum up, bio-based plastics does not necessarily compostable or biodegradable. Biodegradable does not necessarily mean compostable. Compostable always implies biodegradable. Thus, compostable plastics represents a subset of biodegradable plastics and can be decomposed under composting conditions in the short term. The composting process can be classified into industrial composting and home composting. Biodegradation process can be realized with or without oxygen. Thank you for your attention.